Welcome back once again to Criminological Theory. So we're going to take a look at more modern aspects of the same biosocial perspectives of criminal behavior we were looking at in the previous lecture, which obviously looked at the early days of how we came to understand the human body and its connections to obviously behaviors. Now, we are going to start still kind of in a time period that's well before our modern day. And what we're talking about here is we're still looking about 1920s, 1930s, even the 1940s. And what we're seeing is there was a couple different theories and ideas when it came to biological aspects of offending that looked at families, specifically twins as well, and adoption. But eventually it did change as we started to advance science and understand things like neurotransmitters and hormones, which is more of the modern day biosocial theories of criminality, where more modern biosocial criminologists are. The first aspect, obviously, with these families is this nature versus nurture. That's an eternal debate in crime all the time. As a matter of fact, after we leave the biosocial theories in terms of lecture, we're going to move into obviously this idea of society, specifically how society is formed and some of the reactions in society to aspects of criminal behavior. But we're still kind of in this debate, especially in this biosocial school, in this still in these earlier days of could you, in essence, inherit through your genes some type of criminality? So what happened was a couple of theorists looked at individuals who were either behind bars or individuals who were in particularly some of the lower socioeconomic status situations, including what we would consider nowadays like shelters. And they took a look at the families, particularly the children and the mother and the father, and they gave them fake names, right? So H. Goddard comes back around to look at the Calicat family, but another individual, another theorist by the name of Dugdale looked at the Jukes family. This again was not their real name; it was just a name that was given to them. And in each aspect, what they argued, both of these theorists, was that there was some inheritability or heredity, or what we call genetic heredity, because either the mother and the father had some influence on the crime, or like we see here, Goddard argued that the mother had a stronger influence, or certain people in the family were engaged in crime. And they did kind of theorize and state that in these early days, it was likely that individuals engaged in crime because they were inheriting this in their genes, basically. Now, we know in the previous lecture the problem with H. Goddard is eventually he argued for basically eugenics to come into play, eugenics criminology to come into play, where individuals were forcibly sterilized to prevent them from having children. But we see here that he wasn't just looking at it as necessarily a IQ thing. He was looking at it by inheritability through genetics and through the family. What evolved out of that, as we moved out of that, when we started to understand twins and actually had the chance to look at embryos, was looking at twins who either shared the same egg or twins who came from different eggs and wanted to see if there was any difference in what we call concordance or criminality between the MZ and the DZ twins. Now, as you can see here on the slide, you do have a difference in the MZ and DC twins, obviously, because there is the difference not just with the egg, but also the same gene material. Again, Dugdale and Goddard are looking at families and arguing this heredity, that they're passing on genetic material that is causing these individuals to get involved in crime. These twins are looking at that same possibility. Is it the genes? And then the concordance rate, which is there any type of disability, whether it is specifically related to criminality or particularly some type of things like psychiatric disorders. Later on, I looked at genetic disorders, and the concordance rate basically breaks down to the fact that the MZ twins had a greater concordance rate because they shared the same genetic material, 100% of it. And then there was an aspect of the criminality where basically we found that there was an expectation that in one study that 52% of the MZ twins were likely to be involved in concordant criminal behavior, whereas only 22% of the DC twins were involved in criminal behavior. So that was then arguing there's some moderation between the influence of genetics, and it really required whether you shared basically 100% of the same gene material. Building out from that, from specifically an individual by the name of Mednick's study from 1927 and 1941, they looked again at this issue of nature versus nurture, but now in adoption. And as you can see here, Mednick argued that if the parents didn't have parental criminality, they were less likely than others to commit crimes. And particularly that it was not mediated by adoption. Now, believe it or not, we have looked at adoption, especially in relation to criminality. You'll see as we move on, we've looked at it in other years, but this was the first attempt to really say, is it who you're born to versus who raises you, in the concept of one of the most modern applications of nature versus nurture in American society, which is adoption, right? If you're just looking at the families, yes, that has an application of nurture, but if it was just the genes, would there be any mediation when they are adopted? Because obviously, if there's no criminality in the adopted family, you would assume the children would behave. And even in some instances in this adoption study, which there was criminality with the adopted family, there was some aspect of nurture there, but still they were arguing was nature. They also, in the University of Minnesota later on, and this was in the early 2000s, looked at twins separated at birth, and they kind of repeated some of the things with Mednick, which was that they did have similar tendencies towards risky behavior, particularly if they had been separated and not raised together. So the nature versus nurture question is a lot trickier than it appears. And when we're talking about, something that is particularly heritable or genetics, when it comes to twins, right? We didn't expect that. There was an expectation that it would be for everybody, but not just twins. And we've started to see some pretty radical differences. But still, we haven't really continued to answer the question of, is it nature versus nurture only? In the 1960s, there was an expansion of what we call the XYY supermale. And this looked at individuals who inherited an extra chromosome, so males, and did that have a relation on behavior? So these twin studies and these studies of families were looking at people who had no genetic abnormalities. They were pretty much uniformly the same. What happens when there is a genetic abnormality? And they found that particularly because these men are inheriting an extra chromosome, and we do know we have what's called a gender ratio problem in crime, which is that more men are involved in crime than women, that there was some issue with aggression, particularly behavioral disorders. However, this could not be explained alone by just things like the presence of testosterone. So that kind of harms, but didn't completely break the XYY factor, because if an individual was basically a double male or a super male because of the inheritability of the extra chromosome, you would expect them to be naturally aggressive. They did have some levels of aggression that increased versus others, but not uniformly the same to the point that it was basically anything outside the measure of normalcy, which is just a fancy term to say They weren't that dramatically different than the rest of the population group. They had other behavior disorders, but it wasn't directly just related to things like aggression. So that is one area that kind of basically, it wasn't necessarily disproven, but basically it wasn't as impactful as we thought. But it also started the trend where we said, okay, well, now we know that men and women biologically are born with a sex at birth, male or female. Is there any impact on hormones, so the hormonal difference, or is there any impact related to something else in their basic genetic structure? So you can see here with the cryptogenic studies, it was looking at masculinity and androgen levels and then levels of deviance. And we can see here, individuals in the XYY supermale, there was higher levels of deviance, but then some of the other ones, and they give the acronyms here, Turner syndrome, insensitivity syndrome with androgen, a normal female, Klinefelter syndrome, congenital adrenal hyperplasia, a normal male, and then a Jacobs or an XYY supermale. There was some, obviously, variation of deviance, but it was just deviance. And deviance is a tricky picture, like we saw before. It's not just crime, it is other behavior that could include immoral behavior. So it wasn't necessarily just criminality. You see here, the XYY supermale is not that far off from a normal male. If you're looking at the percentages, not that far off, especially with androgen levels. So what that really showed was testosterone was one of the biggest hormones we needed to take a look at, right? And we do know that obviously it is a hormone that increases aggression. Now, the concern becomes then, is that the only reason why more men are involved in crime than women? Because estrogen, especially as it says here, before the menstrual cycle begins, so basically premenstrual cycle issues, which obviously means that there's an ebb and flow in the time in which the hormone levels are present in the body and the intensity of them. There actually are some proof to show that criminal behavior and risky behavior, even aggression, increases during the premenstrual cycle for women. Is it just testosterone? Well, no, if there's estrogen mitigating it, then testosterone isn't just the only factor. As a matter of fact, we do widely believe that testosterone is mitigated by the social environment, so how the boy is raised. But it is interesting that higher levels do increase aggression. And we do also have this correlation, for example, with men who abuse testosterone supplementation with what we call roid rage. So obviously, there's some direct things related to this aspect of we are finding aggressive behavior, but is that the only thing that involves and explains criminality? And it's not entirely clear to explain the gender ratio issue, but we're getting somewhere and saying, yeah, this is pretty interesting for study. And as I said before, the hormones fluctuate. We can see here for both men and women, there's a difference in the time period. For men in the morning, higher levels of testosterone. For women, higher estrogen levels at night. So that's important. We would see a difference in offending, especially criminal behavior, in men versus women when it comes to the time of the day. We do see some variance in the time of the day when it comes to offending, but not really anything that's outside basically expected norms. So then the next thing that was looked at was neurotransmitters. How does the brain communicate with the rest of the body in this chemical process to transmit the electrical signals? And that actually is something that is continuing to rise in prominence today because we are trying to understand an increase in criminal behavior in relation to things such as mental health disorders and, for example, mass shootings. One such neurotransmitter we know that is good is dopamine. Wow. When you abuse cocaine or meth, your dopamine production goes up. So you feel better. Well, we know we have in society problems with drug addiction and drug offenses. That could be a correlate to obviously where that crime occurs. These individuals are seeking out a dopamine fix. We also know that there are certain disorders like ADHD in which individuals' brains no longer process dopamine correctly. So, in essence, their brain tries to seek out dopamine fixes in an unregulated fashion, and it can cause them to have problems with not only regulating normal behavior, but even things such as keeping track of time. So, could that explain risky behavior? Well, we know that there is some connection now between bad dopamine processing in the brain and addictive behaviors. It's not the only thing that correlates to addictive behaviors, but it is one. Well, then, in a society like the United States where we have high number of drug offenses, that could possibly explain the addiction problem and then the correlation to criminal behavior. Serotonin is another one. As a matter of fact, if you don't have enough serotonin in your brain, you're more likely to commit crimes. We need it not just for information processing, but serotonin also makes you feel good. It helps with a lot of calmness in the human brain. Well, in the last 30 to 40 years, there has been a large increase in giving children not only drugs that are focused on producing greater amounts of dopamine. So this would be your ADHD drugs like Ritalin and Adderall that try to boost certain levels of brain chemicals in the brain. But we've increased the production of SSRIs to help with mental health. If we are raising the low levels of serotonin in people's brains to help them with depression, with anxiety, with panic disorders, why are we still seeing serious criminal offenses? If that was the only thing that explained these criminal offenses, then by having a drug that increased the low levels, we should be able to basically root out crime. And it should be showing you in the suggestion of social biology, we're starting to get a bigger picture of it's not just the human body, it's also society. Another one that's come into prominence since the discovery of CTE amongst professional athletes is brain injuries. TBIs present a dramatic risk for criminal offending. The prefrontal cortex of the human brain, so in the frontal lobe area, does not fully form in human beings until age 25. There are some people where there's a variance in that time, but 25 is the median age. When there are impairments to any part of the frontal lobe, where you see on your slide what the frontal lobe is responsible for, we do see that individuals are engaged in aggressive behavior, more likely to engage in risk-taking behavior, and are more likely to be engaged in issues related around addiction as well. So we are very, very closely monitoring in the criminal justice system the rate of brain injuries of offenders. And as a matter of fact, one of the possible videos that you can watch for this week looks at the rate and amount of brain injuries in the population of individuals who are in our prison system and what impact that can have, including when we talk about executive functioning. Well, are these individuals are more likely to miss, for example, their report-in times for probation and parole and other important things that they're required to do, like going to their job, because their brain is unable to process the information that they need. And you can see here what we do post-mortem is we dissect the brain. And what here is actually a picture pulled out of your textbook is the brain of John Wayne Gacy, a serial killer. And they wanted to try and understand, is there some difference in John Wayne Gacy's brain that caused him to basically become a monster, if we want to use that terminology. There have been variances with a lot of serial killers. Ted Bundy's brain was dissected after death and there was no abnormalities. Other serial killers have presented with prefrontal cortex impairment, or it didn't fully form correctly. Others have presented with tumors in their brain. And now, with the study of CTE, they're going back and looking at the brain sections and seeing if there was any connection between traumatic brain injuries or TBIs and the presence of things like CTE. We also track the brain waves, and each of these brain waves have a responsibility in determining different aspects of behavior. And when we look at these brain waves, with the presence or lack of presence of them, can be correlated to some nature of any type of offending. This is also discussed not only in the text and the readings that are assigned for this week, but also in a video that I put up. So for the purpose of this lecture, I'm going to obviously just stop on the fact that there are 4 patterns, but we're going to continue on to the central and autonomic nervous system. And each here, what we find is with the central nervous system, if an individual has a particular brain wave present, there's a likelihood of increased criminal behavior. The same thing is present with individuals who have dysfunctions in their autonomic nervous system, including some abnormalities related around individuals who have low resting heart rates. We actually have found that individuals who have low resting heart rates naturally, which is controlled by your autonomic nervous system, actually are more likely to be engaged not only in criminal behavior, but they also might be a possible risk factor for criminality. And we now know that particularly that other autonomic nervous system differences, including how the skin responds on the through the electrical system, and also how you sweat as well, could present some presentation of criminal behavior. Particularly people who have low galvanic skin response rates actually have a greater likelihood of being engaged in criminal behavior. So it is interesting then that whether it's a particular brainwave or a particular controlling of things that you don't even know exist, it's involuntary, right? You don't control your heart rate, you don't control your breathing, you don't control. Well, I mean, outside of obviously meditation or measured breathing, you don't control your sweating, for example, unless you particularly put yourself in a situation that can raise or lower your raise or lower your body temperature. We are going to find that there are differences in human behavior. Now, as I mentioned before, ADHD is also a big one, and there is problems, obviously, with how we look at this, particularly when we look at individuals who have this disorder. There is a greater correlation, not just with individuals who have possible gambling addictions or drug disorders, but also just functioning. And this really hurts in the criminal justice system around things like parole violations and probation violations. And what we see there is that the individuals will often actually get in trouble with the criminal justice system, and they're not actually meant. They're not actually something where they should be put behind bars necessarily for that. So when you look at it, what you find is that one of the biggest correlations, whether it's ADHD, do you have a particular alpha rhythm in your brain, or do you have a low resting heart rate? These may be predictive factors for criminality. And you can see here on this picture that pulled out from the CNS, there's a lot of things that occur naturally. So whether your pupils dilate, whether you're able to produce saliva, what your heart rate is, how well you breathe, how well your body processes food, all of these things are factors of the central nervous system. So what we've been trying to take now in the modern day in explaining criminal behavior is this mitigation. And actually the formula we use is G times E. So G times E. Possibility that there is genetic factors that come into play, but it's mitigated by the environment. It's mitigated by your friends. It's mitigated by your family. It's mitigated by social institutions. It is a complex picture of you might have risk factors towards criminal behavior due to things that you have absolutely no control over. Inheritable disorders, inheritable diseases, inheritable differences in your chromosomes, but the environment is the mitigating factor. We also now are taking into account things like diet and exercise. We look at sugar, for example, and deviance or erratic behavior. We look at exposure to individuals who have problems with food allergies and why, for example, individuals with peanut allergies can actually be more aggressive than other people. And that could be due to what type of basically hormone is produced in response to an exposure to a food allergy. We look at things related to just in general hunger. The whole terminology of hangry, for example, is often explored in diet and exercise. Are there any differences in individuals who have vitamin deficiencies? Well, there's reason to believe. Or even just exercise in and of itself. Exercise does help produce healthy hormones like dopamine, so it does keep us happier. And then when you're developing in the womb, we know that androgen exposure has a dramatic impact on your future development, including things related around testosterone exposure early on and whether that can cause issues with growth and also issues with obviously future inheritable diseases. So we also know that within your environment, your exposure to dangerous toxins is important. As a matter of fact, what I often ask my students in criminology in the undergraduate level is, do you know where the phrase mad as a hatter came from? For the Mad Hatter in Alice in Wonderland. Now, if you do, we know that it comes from the fact that when individuals used to make hats that were made out of animal skins, particularly animal pelts, they used mercury to cure the hat so it wouldn't erode away, so it would last longer. And it would also take the shape that they need. Well, mercury is known to cause, in high level exposures, is known to cause psychosis. Lead causes developmental disorders, a reduction in uh, IQ level, which can lead to problems with learning. It also causes problems with growth. The numerous amount of toxins that are present in smoking, which you see here on the figure slide, are especially early on, not doesn't just hurt stunt your growth or hurt issues related to the capacity of your lungs, for example, but has correlations with your exposure to chemicals that you're not supposed to have present. As a matter of fact, with lead in and of itself, that's the reason why not just the toxins in the air, but particular when we're talking about what it was doing to the climate and the ozone, but particularly to children, we believe may explain why the 70s, 80s, and 90s were particularly bad in the United States when it comes to things like serial killers and serial offending. When lead was heavily available in the environment, we believe that may have a correlation with individuals who went on to commit some of the most serious offenses in society. So, like every other chapter, we leave with policy implications. One of the things we encourage, obviously, is preschool for all children. We want to make sure that we mitigate some of these genetic factors with the environment. Get these kids into a suitable environment in which they can learn and grow and learn how to get along and socialize with other people, how to grow their ability to do things like base level mathematics or even just share. We need to focus, with social biologists argue, we need to focus on healthcare for when women are pregnant. We need to get involved in terms of helping women give birth to healthy children. So making certain that they have access to prenatal vitamins, that the mothers themselves are healthy, and that the children are healthy in the first few years of life as well after they're born. to the point that one of the best things we can do as well through the doctors is checking your hormone and neurotransmitter levels and checking in on the environment, including your exposure to chemicals and all, and make certain that early intervention, especially on the school level, can intercede before obviously you go down a pathway of delinquency, which would lead to criminality. And it can include the same thing for adults who have traumatic brain injuries. Can we intervene, including in the criminal justice system, before they uh, leave it, before they, in some measure, leave either the criminal justice system entirely, or when they leave prison, for example, they don't come back on technical parole violations if they have things like a TBI. I hope that this information was helpful and useful for you, and I thank you for your time.